Jonathan Walker as part of an applied data mining project for Rockhurst University. Overview of what I'll be doing today is I'll be talking a little bit about the data, some steps taken using R programming, creating a decision tree, creating linear regression models, the results of both of those, prediction of results based off of a new customer added in a new data frame, some recommendations, and lessons learned. This data was retrieved from the University of California, Irvine School of Information and Computer Sciences Machine Learning Repository. This is a link where you can actually access the data. And the data was obtained from credit card default data in Taiwan. And it was donated to the university in January of 2016. The variables provided against whether or not a customer would make their next payment on their credit card versus their credit limit, their gender, their education level, their marital status, their age, the history of their past payments, the amounts of their bills, and the amounts of those payments on the bills. After I did a little bit of cleaning, removed a few unnecessary columns. Some steps I took using R programming, just a basic overview, was first I went through the process of creating a decision tree, then I went through the process of a linear regression model, and then I created a new data frame and predicted the outcome of that customer, whether or not they would default on their next credit card payment. First, creating a decision tree. I cleaned the data, I reduced the number of variables down to about 6 variables based off of just socioeconomic data, their gender, their marital status, their credit limit, their education level, just to kind of see the decisions based off of those factors. I created a testing and training sample with a 70-30 split, which is pretty standard. I utilized the RPart plot package to create the decision tree. I ended up with only a root. My results were the RPart plot tree was not successful, and obviously there were not enough correlations in the variables that could be found in order for the package to create a decision tree. So after I was and then once I created the split and created the training and testing models, then I created a tree and ended up with only a root. After being unsuccessful in creating the decision tree, I decided to create some linear regression models. I wanted to see the correlation between various variables to kind of see the impact on whether or not it had an impact on someone defaulting on their next credit card payment. First, I started with 2 simple linear regression models. The first one was whether or not a customer would default on their next payment versus their credit limit, and then another one versus their age being equal or greater to 30 years old. After that, then I created 2 multiple linear regression models. The first one was the correlation between whether or not they defaulted on their next payment versus their education level and their age. The second model was the correlation between whether or not a customer defaulted on their payment and all of the variables that were given in the original data set. The first model, this is the correlation between the default on their next monthly payment and their credit limit. The first model showed that there was a greater, that the greater that their credit limit was, the less likely that they would default on their next credit card payment. So higher credit limits equals obviously less risk. So they're probably more trusted customers, and that's probably why they have higher credit limits. The next one was the model that showed someone being greater or equal to the age of 30, which I tried to correlate maturity and whether or not they would default on their next monthly payment. There was really no correlation between the two. A customer making their next payment versus their education and age. There's a higher correlation between their education level and defaulting on their next payment than their age. Their age did have some correlation. I used the entire age spectrum instead of being greater than or less than 30 years old, and there was some correlation, but it wasn't extremely significant. Next, I made the correlation between customers making their next payment and all of the variables in the original data set. The significant variables that were indicated were their overall credit limit, their education, their marital status, their age, their payment tardiness on their first two credit card bills that were listed, the amount of that first bill, and then the payment amount on that first bill. I did perform the Durbin-Watson test on the second multiple linear regression model, and it did indicate a positive autocorrelation. That second multiple linear regression model against all variables, and I decided to go ahead and create a new data frame to predict all the chances whether my new customer would default on their next credit card payment. So here's the data frame I used. I have a credit limit of $25,000. I'm a male with a graduate level education, 26 years old, married, I have 3 credit cards. I've only been late on one of them, and it wasn't significantly late. The bill amounts were $5,000, $1,500, and $32.50 on those 3 credit cards, and on those I paid $1,500, $1,000, and $50. The data frame that I provided for this test customer, the chances of me defaulting on my next credit card payment are 20.3%. So I'm not very likely to default on my next credit card payment. I would recommend using the final multiple linear regression model that I created to predict whether or not a customer would default on their next payment. The Durbin-Watson test did identify a positive autocorrelation, which means I would be likely to want to use that model. From this project is that not every data analysis technique is applicable for all data sets. My example being my decision tree. My decision tree was not successful, and therefore it was not applicable for this data set. The next one is that outcomes and correlations are not always as expected. Just because going into this project, I thought that maybe someone being older and being over the age of 30 might have an impact on whether or not they default on their next credit card payment. That's not necessarily true. And cleaning your data too much can limit your analysis. when I cut out a lot of variables, I didn't have much correlation. But then whenever I added all variables, more than just the socioeconomic data, I found some correlations that were unexpected. And it really, it opened my eyes that maybe you should perform certain analysis before you start cutting data.